Alright, so a couple lessons back, we introduced the, well, this type of general form where we can go ahead and find a point, given a point, we can go ahead and draw it out and do all of that. So we can go ahead. So if we had a point here, we was able to connect it and be like, oh, this is a sine value, this is a cosine value. So today we're going to do the same thing for tangent. And we're also going to introduce you to one of the most fundamental ideas in trigonometry, that being the exact value. So if you look over here on the left, you will see two triangles with some values filled in, but not entirely. So you may question at first, hey, what are these values? And you're like, hey, wait a minute. Yeah, what are these values? So they aren't difficult values to look at. So let's just imagine we have let's say we had this triangle like this. So this is 1, this is 1, this is 1. So equilateral triangle. If I slice this in half, this now becomes half. So we can also write this part as 1 as 2 and this part as 2. Now using the Pythagoras theorem, we can figure out this is root 3. Right? So we have proved the left triangle over here. So this triangle on the left, we proved that. So on the right, that's just slicing it in half. That's not the same anymore. So what if I had 1, 1 here? Right? 1, 1. And then root 2, right? That's Pythagoras theorem. And this is 45 degrees, this is 45 degrees. And now we can fill in the table if we had the sine and cosine and blah 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 and stuff. So this class we're actually going to learn how to use these values. So let's start with something here. So this time instead of giving only cosine and sine, we're actually having to include tangent here. Let's go ahead and draw -3 and -6 somewhere here. So we're going to draw a line here. This is -3, this is -6. So the sine value, and okay, for the side, this is going to be 9 plus 16, which is 5, right? No, 9 plus 36, I'm sorry. 9 plus 36, which is square root 45. So square root 45 here can also be simplified. Remember we did that earlier, so we take out a 9. We take out a 9, so this becomes 3 root 5, right? So our sine actually is, for this angle right here, we're doing opposite over hypotenuse. So -6 over 3 root 5. Cosine is -3 over 3 root 5. The 3 cancels out, also is -1 over root 5. And then we can rationalize, but we're not doing that right now. Tan is just simply opposite over adjacent, so negative, so that's 2. So I want you guys to take a look at it for a minute and think about it. Hey, is there some sort of pattern that I see here? Like, what is this? Why is the sine and cosine negative and why is the tangent positive? So remember we introduced the CAST, or the All Student Take Calculus unit circle that determined whether something is positive or negative a couple classes ago. So use that and let's move on to the next question. So let's go ahead and finally do some exact value. So we have this angle of 120 degrees, and we kind of want to find the exact value of sine, cosine, and tangent. So let's first draw an angle of 120 degrees first. So it would be somewhere around here. This is 120 degrees. So, how are we going to approach this exactly? Well, we're going to go ahead and first let's do some values. So, earlier, whoa, that's not what I meant to do. What? I'm not printing onto the layer. So, earlier we did something like we did this little triangle right here. Let me refresh real quick. So we used that little triangle on the left that I showed you, this one, and we have some exact value. Now, if you look carefully, hey, wait a minute, that is the same angle. I mean, look, this is 60 and that's 30, right? This is the same angle. Except we have a -1 here. So now, let's go ahead and actually fill it in. So we have all of this. So sine would give b opposite over hypotenuse. Sorry, so 2 over √3. Cosine would be adjacent over hypotenuse, so -1 over √3. And tangent would be opposite over hypotenuse, so 2 over -2. Right? Oh wait, sorry. So we messed it. So I messed it up. Sorry guys. So this is √3. 1, 1, whoa, 1, √3, and 2. So sine would actually go ahead and be equal to √3 over 2. Cosine would be -1 over 2. Tangent would be √3, -√3. Alright, so this is how we solve it for now. Right? And then we're going to learn a little bit later about, the exact value and stuff. So let's go ahead and do this. We're going to directly do some exact trigonometric ratios from the radian measures. So let's find the exact value of this. So first, I like converting it into degrees. So let's go ahead and convert this into degrees. So 7 times 180. 7 times 180 divided by 4. That's going to go ahead and give us 315 degrees. Oh, wow. Keyboard. Sine of 315 degrees. So let's go ahead and draw that angle real quick. So it'll be something like this, right? It'll be something like this. So 315. So what is that angle left on the right of it? That is 45 degrees. So this is 45 degrees. So let's go ahead and see what we can do. So this will be 1, and this will be 1, and this will be √2. Right? So let's go ahead and calculate. So the sine of this should equal to opposite over hypotenuse. So 1 over √2. And if we rationalize the denominator, it's going to be √2 over 2. Right? No questions? And we forget the negative sign, because this was -1. So -√2 over √2, -√2 over 2. Okay? And then let's go ahead and do b. So let's convert b to a degree as well. So 5 times 180, I'm going to divide that by 6. So that is going to go ahead and give us 150. So cos of 150 degrees. Let's draw that out. This is 150 degrees. And if we have this triangle left here, that is what? 30 degrees? Right? So this is 30, then this has to be 60. Because remember, this is like the reverse of this. So this is like the reverse of this. So now if we have 30 here, where is it? If we have 30 on the bottom, we'll have 1 here. And we'll have 2 here. And we'll have -√3 here. Right? Because we're in the negative x value. So let's go ahead and find the cosine of that. It's going to be equal to adjacent over hypotenuse, -√3 over 2. And that is our answer. So now we're going to do a little bit from a right triangle. So let's find the value. So if we have a right triangle, we don't have to do anything. That's it. So now we look at it and be like, hey, wait a minute, but we don't have any angles for that, right? Well, it's okay. We don't need any values. So let's just say this is 1, 1. And this is √2. So if we had sine, so we can't actually draw any triangles since there is no triangle. Since this is the triangle right here. This is our terminal arm, and this is the triangle, unfortunately. So the only point we have is 0, 1. So let's do 1 here. 0, 1, 0, 1. So now let's do some sine. So if sine 90 is equal to this. So this accounts for the hypotenuse and the the radius. Remember? So sine was actually equal to y over r, and then cosine was equal to x over r, which in this case is 0 over 1, which is 0, right? So now, however, for tangent it's a little different. It was y over x. So our y value is 1, that's fine. But our x is 0. So that is actually undefined, right? So we're done. So we're going to go ahead and wait till a couple class later, and then we're going to be able to find out why tangent at this point is not defined, and there's going to be much more easier ways for us to go ahead and look at it. Well, to find exact values of sine, cosine, and tangent. Then let's talk about this example 5, which is operating a crane. The boom of a crane can be moved so that its angle of elevation changes. In one location closest to some building, some overhead power cables, the minimum value of angle of inclination is 30 degrees, and then the maximum is 60 degrees. And they gave you the diagram. If the boom is 10 meters long, find the vertical displacement of the end of the boom when the angle of inclination increases from its minimum value to its highest value. So basically, we're only looking for the vertical displacement. We're not looking for the horizontal and the vertical part. So let's go ahead and do that. So how are we going to do this? First, we have to find y1. So let's find y1. We had 10 meters here. We had 30 degrees here. We're trying to find this. So if this is 30, this is 60, right? Because we have a 90 degrees angle. And now, hey, look, wait a minute. That's one of our special triangles. So this is 1, 2, and root 3. So now technically, if 10 is equal to 2, so what is 1? 1 is 5, right? So y1 is equal to 5. Because it follows a ratio. If that ratio is 2, there's no way it's going to be different. So y1 has to be 5. Now let's go ahead and so we drop that down. Let's drop that down. So this is, and then let's go ahead and do this again. So y, and then let's do y2. So this is 10, and this is 60, and this is 30. So now, remember our formula, which was, remember our special triangle, which was 30, 60, 1, 2, root 3, right? So now if we flip that around, this would be still 2. However, this is root 3. So if we found out if 10 is actually 2, so what is root 3 equal to? So 10 divided by 5 is equal to 2. So now, we also need to find what divided by, so we just find root 5, we multiply this by 5, we'll get the actual value. So 5 times root 3, because it follows ratio, right? So now this is y2. So all we need to do now is to do 5 times root 3 minus 5. So now this is the exact form, because we can't simplify it any further unless you want a common factor and be like, hey, look, this is the common factored form, right? This works. Now the actual value, which is what we're going to do right now, so let's do 5 times square root of 3 minus 5. It's going to go ahead and give us 3.66, which rounds up to 3.7 meters. And therefore, that is our entire lesson related to exact values and the special triangle. So if you want to, please memorize this chart. If you don't want to do that, go ahead and memorize how to work out these triangles. Go ahead and prove it on the test. There are a little bit of a funny thing, well, some smart ways to memorize this table, which I will show you in the next class. Well, okay, I'll talk about right now. So the 30 and 6, you will realize that cosine and sine is closely related. So the sine of 30 degrees is the same as 60 degrees. And the sine of 60 degrees is the same as cosine of 30 degrees. While the 45 is the same thing. So that is one of the easy ways to remember it. And then tangent is just by itself. So it's 1, 1, and root 3. That is pretty much how you memorize it. You can just, the rest, I really dislike the fact that you're going to memorize. But Please, guys, this is a trigonometry unit, and this is why many people dislike it. It's because there's a lot of memorization. However, really, if you know how to do the math, it's much more better than just memorizing. So if you know how to prove the triangles, definitely go for that. Okay, that's the end of this class. If you have any questions, go ahead, reach out to me, and that's it.